event-driven high-performance dashboards with DynamoDB Materialized views and Kotlin Lambda. Are there people that are using Kotlin in the room? 1, 2. Oh, that's good. That's good. Better than I thought. OK. So before I dive into our solution, first I want to give some context into the problem we're trying to solve. And the main actor in our problem is a role container. No, it's not the role container you're thinking about. So what is a role container? Role container is used at PostNL everywhere. And we use it to pick up the packages at a customer, to transport the packages into our sorting centers, to group the packages into, so we know where to the destination they were going to at the sorting centers, and then we can deliver them to distribution centers, which would then be the closest to where the packages should be. So the role containers can be transported by trucks. They can be moved manually, like rolled. And then they can also be forwarded away. Right, so let me just do that. They can also be forwarded away when not in use. You can see the ladies there forwarding their role containers away. They're putting the bottom up. In the other picture here, you can see that the role containers are actually filled up with products at the customer site. So what we did, we fitted our role containers with beacons, Bluetooth beacons. So we know where they are, if they're traveling, we know that they're traveling. And we also can sense if they're in use. So when they're in use, the bottom is down. And when they're stored away, which is the bottom going up, then we know that they're stored away and they are available. So some fun facts about role containers. We fitted about 300,000 role containers with our Bluetooth beacons. And we can track them in more than 10,000 locations. The role container system gets actually more status updates than Twitter, even with all the bot users that apparently Twitter has. So when we know where our role containers are, we can plan the transport more effectively. And when we know where all containers are, we lose them less. You don't want to lose those. So where are all those role containers? How can we use that data to actually improve our delivery processes, to streamline them, to prevent any problems happening, and to prevent delays in our delivery systems? So basically, at Mission Control Platform, we currently create dashboards. There's a lot of systems that actually use that data in different ways. So what we do is we help the users on the floor to manage and plan and prevent the problems from happening. And we need to collect that data and actually display it in a way that will be helpful to the users on the floor. So how do we get from the raw data or raw events that is being sent by our sensors to us and then create useful views? So this is, for example, actually showing how long a role container has been standing still at a certain locations. And this shows the top 6 locations which has the longest standing still role containers. And then you can filter and sort it on the different criteria, like how many, or type of role container, or type of location, and so on. So, so what we do is we collect events. And I already told you about the IoT events. So that's the sensors that are sending us information. But that actually tells us where they are now. It doesn't tell us what they're doing, and it doesn't tell us what products are in there and where they're heading. So for that, we need scan events. And scan events are actually generated by people working on the floor. They can scan a label that's on the role container, and that label tells us the priority of the role container, the customer that the products belong to, the type of products that are in there, and where it's heading. So now that we've got all this data, how can we get to where we want to go? So what are we working with? We're working with fully serverless at PostNL. Only serverless, no, EC2s not allowed. We've got large volumes of data, which I already mentioned. So a lot of events coming in. We want sub-second performance, so when users look at the dashboards, you should really see it immediately. You don't want to be waiting for anything. We process the raw event data into something that's useful, and therefore we need to do data aggregation, filtering, sorting, and we have a Kotlin Java engineering team. So that brings me to the main topic of the presentation, and that's event-driven high-performance dashboards with DynamoDB Materialized views and Kotlin Lambda. I will start with the DynamoDB Materialized views. So what is a materialized view, actually? That's basically a pre-baked result of a query. So if you execute a query, you get a result, and you save it. That means that any consumer of your data can retrieve it really, really quickly. So let's have a look how we've done it with DynamoDB. This is a really good example. I don't know if you can see it, but basically, that's a good example that I can show how this is implemented. You have on the right-hand side, you have filtering columns. So we can filter on the location type, on the network, and on the raw container type. Is it big, is it small, what kind of add-on it has, and so on. So when we filter, the top 6 of locations which contain raw containers that have been standing still for a certain period of time changes from the 10,000 that we have. So then you want to see actually the top 6 with the highest count based on your criteria, and maybe you also want to sort on the amount of days it's been there. So how do you do this in Dynamo? So what we do is we make sure that everything you see on screen is actually saved in one object in the database. So once the user selects a criteria, what they want to see in their report, we actually fetch the whole thing and display it. And you can see here, how does it look in a Dynamo? We have an object which has a list of all the rows that you see in that dashboard table. And that highlighted row is actually the one displayed there. So basically, you see all the counts in that row, and that's how we display it. So it's really, really fast. So what are the wins of using materialized views? We have sub-second performance. Yeah, obviously, you guessed that. We also use integration with AppSync and velocity templates in order to expose our data with GraphQL, which allows the user interface to actually fetch the data. This is really fast for our development team to actually implement that. We have component decoupling. Every materialized view is obviously independent of any other materialized view. Every time we add one or we change anything, we're actually not affecting anything else. There's no logic in the front end. Well, obviously, we pre-baked everything, so you get what you want to show. So you're only concerned with styling it and not actually concerned with doing anything with the data. So what are the challenges then? I think you guessed some of those. Well, obviously, you have query limitations. Because we pre-bake all the results, that means we know all the queries that you're going to do in advance. So you can't generate the queries based on the customer selection or user selection, because we have to actually run them and already save the result. Reusability. Of course, if you have materialized view, it's specific to the consumer of your data. So it's really difficult to reuse that. So you also have maintenance overhead. And that basically means that if you want to change anything, then you need to make sure that the software that generates your materialized view needs to be updated. So you can see the balance. You want performance, you want really fast and cheap access, but then you have to have some sacrifices and you have to balance on that. So because I already mentioned that we're going into the maintenance part, so what actually generates our materialized views? And we're coming to the Kotlin Lambdas. So before I go into the reasons why we chose Kotlin, first, because there's not a lot of people using it, I was going to tell you, introduce the language. So somebody actually asked me, is it not a language that people use for Android mobile programming front end? Now, actually, it isn't. It's actually a general purpose language that was invented 11 years ago by JetBrains and was actually only adopted by Google for their Android in 2019. And it's been used for backend by quite a lot of big and small companies like Google, Netflix, and PostNL also, but Bol.com, NS, and Jumbo, Albert Heijn, ING, Rabobank, and also Amazon, because Amazon actually made Amazon Quantum Ledger database with Kotlin, if somebody didn't know about that. So let's have a look at why we chose Kotlin. Well, firstly, we found that it has a really fast and efficient execution. And I'm coming to that now. So it supports lightweight concurrency. So instead of threads, you use coroutines, and that means that it will be a lot more lightweight and faster. It supports AWS SDK, so basically you can use the AWS SDK, which means your development time will be shorter. It's agnostic of AWS runtime. This is what I love about it as well. So we can run the latest version of Kotlin, which is now 1.7, despite of any runtime on AWS. So for example, if you're running on JVM runtime, JVM 11 on AWS, I can still use the latest version of Kotlin and use the latest features. This is brilliant. So it runs on ARM64 architecture seamlessly, which makes it also fast and efficient. And it's multi-platform. So you have a choice between platforms, what you want to use. As you are on serverless, you do want to look at that. So what are those platforms? So I mean the runtime platforms. So you have JVM, the choice. You have a JS, so Node.js runtime on Lambda. And you have native. So native has two flavors. And I chose specifically GraalVM because this actually is supported by the version 2 SDK of AWS. And the LLVM is not yet supported. There's like a work in progress SDK at AWS that's not ready. So we're going to go with GraalVM. So how do we choose between the three? So we decided to actually make a performance test because that's exactly what we want to choose on. So before we made a performance test, we wanted to look at the benchmark. What do you compare? Obviously, you don't want to do hello world. It doesn't tell you anything. It's like useless. So we took one of the lambdas that generates our materialized view, and then we made sure that it runs on the 3 runtimes, and then compared. So generates DynamoDB Materialized view. We used one of those lambdas that does a parallel scan on DynamoDB, and therefore we could use lightweight concurrency to support that. And in order to be able to compare, we used the Lambda Power Tuner to generate executions, so we can compare them. And we compared on different Lambda memory size to see if there are any differences on that. So let's have a look at the result on the cold start. So on the cold start, people that are familiar with JVM on serverless, so you're not surprised with this result. So the JVM is the big loser, with 15 seconds on 1,000 MB memory, followed by JS at 5 seconds, and GraalVM, a big winner, on 1.5 seconds. As we add memory to the Lambda, the difference reduces, or the difference becomes less between the 3 runtimes. And we see that with 4,000 MB, we have 5 seconds on JVM, 2 seconds on JS, and we have only half a second on GraalVM. So the GraalVM in this case is a big winner. So let's have a look at execution time. So the cold start happened, and then the Lambda is warm, or we use something to make sure it's always warm. So what's happening when it's executing, actually? Is it, yeah. So is it the same result? Well, actually, no. In this case, the JS version is the least efficient. So on the 1,000 MB, the JS version is almost 4 seconds, whereas JVM was at 1 second, and closely ahead of it is the GraalVM native version at 900 milliseconds. So as we add memory, then again the difference reduces, and we have the JS version at 1 second, with JVM at just under half a second and GraalVM at 300 milliseconds. So you can see that the JVM and GraalVM are really close to each other, with GraalVM about 100th of a second faster. And the JS is like lagging behind there. So if I get my slide again. Right. So is Kotlin native the silver bullet? I think so, yes. I think it is a silver bullet. I'd like to compare it with Rust. Actually, I need to get somebody that's good at Rust, write it down, and let's have a fight on who's faster. Okay, so anyway, so let's zoom in on the native Kotlin. AWS SDK version 2 supports GraalVM native. You can actually use it on Java. If you don't really like Kotlin and you want to stick to your Java, you could still use that and then go native. So ARM64 architecture for the latest version of GraalVM is available, so you can be faster even. But you do need to provide your own runtime. So if you run on JVM, you can use the AWS supported or provided runtime already. If you run on JS, you can use the Node.js runtime from AWS. But if you want to run native, then you have to provide your own. And basically, we just use the Docker image to do that, so that's not really difficult. And what I already mentioned, that the Kotlin AWS SDK is work in progress for the other native variant. And when that's out, we can also do a comparison and see if that's even faster. So how do we use it in architecture? Oh, there's the event bridge again. Yeah, sorry. Yeah, so obviously we have the two sources of our events, the IoT events and the scanning app. They're coming into our event bridge, which is an entry to our platform. Then we have our Kotlin Lambdas that will be triggered by the event bridge, and they will process the raw data into the raw Dynamo database. And then we have two flows, the real-time flow, where you actually want to see that raw container leave the building or enter it in real time. And then we have a reporting flow, which basically means we don't care about real time. We just want to report once an hour, once a day. So the real time uses Dynamo Stream to trigger Lambda and update the materialized view with the real-time data, which is exposed through AppSync and GraphQL to our API, to our interface, so we can show it on screen. And the schedule Lambda just generates the whole materialized view, and that's also exposed through AppSync with GraphQL. And then our front end can get the data. So front end does the connection authentication through Cognito, and I welcome just to a small thingy so it's secure. Right, so to conclude, DynamoDB Materialized views are good for performance. If you want really sub-second performance, you can use that for snappy results, for data aggregation and filtering, but it is best used when you know your access patterns, when you know the queries that's going to be run. If you are using Kotlin, go native. If you go native, you will reduce your footprint and improve your performance. And if you want a challenge with me, and you know a language and you think you're faster, keep in touch, and let's do it.